Welcome back. In our previous video we were discussing the differences between series circuits and parallel circuits, discussing what current does, what voltage does in both situations, but we didn't quite get around to doing the numbers in this case. Now, in this exercise we've said that we would connect two resistors, both of 12 ohms and 36 ohms, in series and parallel circuit, and we would connect them up to a 9 volts source in this case. This gives us enough information to get to calculating. If you want to calculate what goes on, you have to do it in steady steps. And the first step is always, so step 1, is always calculate your total resistance. So ironically, the bit that we discussed last in our previous video is the bit that we should be doing first. Now, it's very easy in this case. You've got one resistance of 12 ohms, you add it to one of 36 ohms, and you end up with a grand total of 48 ohms in this case. It gets trickier, however, if we do step 1 in our parallel circuit. In our parallel circuit, the reverse of the total resistance, in this case, is 1 divided by 12 plus 1 divided by 36. Good old fractions. In order to solve these, that means that we're adding 3/36 to 1/36, or the grand total is 4/36. Now remember, this isn't your final solution. This is the reverse of your total resistance. So in order to calculate your total resistance, you would have to add, or you would have to reverse your fraction in this case, which would be 36 divided by 4, or 9 ohms. You might be thinking, like, this is odd. The total resistance is less than both of these resistances in my actual circuit. But I told you in the previous video, it's logical when you think about it. If you connect several different pipes in parallel between one vat and the other, it will actually be easier for the water to flow from one vat to the other, meaning it'll be a lower resistance in total. Alright, having done step 1, you can switch to step 2, and I'll use the same color that I've used before by calculating your total current in this case. Now, how can you calculate the total current? Well, you use Ohm's law. It would be your total voltage in this case that you divide by your total resistance, which is why you first had to start out with calculating your total resistance, or you could not use Ohm's law in this example. Now that would be my 9 volts divided by my 48 ohms of current in this case. If we quickly grab our calculator, we punch that in, it means we would be talking about 1.1875 amps flowing through. Now, the total current we have in the parallel circuit will be different. It will be, so your total current, I'm not going to write the entire equation again because that's a bit silly, but it would be my 9 volts divided by that 9 ohms that we calculated in the previous step, meaning you would get a lot more current in this case, 1 amp. Which means, if we look at our situation, there's 1 amp of current starting here, and there is 1.18 or 0.1875 amps being generated in the series circuit, like this. Now if I wanted to, if I'm at this step, this is where I have to apply common sense. You have to see what your circuit is, series or parallel, and then know which of these two values you can copy paste to the other resistances. Previous video we discussed that in a series circuit your current is the same in every single resistance, meaning that is the number you can copy paste for the other ones. While if you're talking about a parallel circuit, it is your voltage that you can sort of copy paste to every single resistance in your parallel circuit. Having done that, you can start using, in your final step, Ohm's law to start calculating the others. What I mean by that is, we can calculate how much voltage each of these is in this case. Why? It's the multiplication of your current times your resistance. What would that be in this case? Well, if I wanted to know that for the first one, I would take my 12 ohms of resistance and I would multiply that by my 1875, meaning 2.25 volts will be on the first one. Now you can do this again for the other one, meaning you take your 36 volt, clear everything here. You take your 36 ohms of resistance and you multiply that by 1875 in this case, which leads to 6.75. Now if you do that, that's one way of doing it, but you could have just used the other law that said that your voltage will divide between those two. Meaning if you know that 2.25 volts is on here and your total voltage is 9 volts, well, if you deduct 2.25 from your 9 volts, this is what you'll end up with as well. So there's more than one way to skin a cat, as they say. You can use different approaches to this situation. We can do the same for our parallel circuit. If we look at our parallel circuit, we know that we can copy paste the voltage, and all we're left with is having to calculate your current. And Ohm's law is right next to it. Meaning, if we do that, we take our 9 volts, which it'll have, and we divide it by the 12 ohms of resistance in the top resistance there, which means it's 0.75 ohms of current flowing through the top one. If I know that the total is 1 amp at the bottom here, I can instantly determine that this one is 0.25 amps. Of course, I could, of course, use my calculator to calculate the exact same thing by taking my current and dividing it by the 36 ohms of resistance I had in this case. And voila, my questionnaire is done. I know what the amount of current is in each resistance, and I know how much voltage is on each resistance in my circuit. There's nothing more I can calculate, and it's all done. These sort of basic exercises are a few that you'll have to do in the rest of the course. There's a few of them further down. But before we do that, let us also discuss mixed circuits in the next video. I will see you then.